Okay, Math 8 students, this is an optional video for you, but would recommend viewing if you have completed your module for review on page 121, the Ready to Go On, and missed some or you're not sure how to solve some, because what we're going to do is we're going to walk through each one of these questions and talk about how to solve it, and sometimes more than one way. So let's go ahead and start by looking at our first question here from lesson 4.1, representing linear non-proportional relationships. So quick review here. The word linear means, oh, here we go. I always forget that. The word linear means line, which means it has a constant rate of change, and non-proportional means it does not cross the origin. So it's a line that does not cross the origin. So we are going to complete the table using the equation y equals 3x plus 2. So let's take a look at that equation and compare it to our slope-intercept form. Right? So this is y equals mx plus b. This is slope-intercept form. And m represents, oh, whoops, dropped the pen. M represents slope, B represents y-intercept. And so this is our rise over run, or our change in y over our change in x. And B is our y-intercept, which is when x equals 0, it's the value that y equals b. And it's our, we can think about that as our starting point on a graph, and we can think of our slope as how we move on a graph, or our rate of change. So we're going to go ahead and complete this table. And so we're going to look at our equation here, which is y equals 3x plus 2. So what we're going to do is we're going to plug in a value for x, which was given to us by our table. So we're going to plug in -1. And so we've got y equals 3 times -1 plus 2. So 3 times -1 is -3 plus 2 equals -1. So y equals -1 when x equals -1. Okay, and then I'm going to show you a shortcut here for 0, right? Because 0 is your y-intercept. This is your b value here. So all we have to do is look at our equation and see what our b value represents, right? Which is our plus 2. So when x is 0, y is 2. And we can, I'm just going to show you how that works here, right? Because if I have y equals 3 times 0, because that's my x value, plus 2, 3 times 0 is 0. 0 plus 2 equals 0. So y equals, sorry, I totally got ahead of myself there. Let's backtrack. 0 plus 2 is not 0. Y equals 0 plus 2, which is 2. So y equals 2. When x is 0, y equals 2, which is represented in our equation with our b value here, right? So when x is 0, y is 2. So you should be able to, when given a set of tables, go through, if you're given the equation and asked to fill in the table, fill in all of your x0 values right away, because it should be your y-intercept here. Don't forget to include that sign. So if this was a negative, that would be a -2 here, right? So then we can continue to plug our x values in to our equation, which would be y equals 3. Our next x value is 1 plus 2. So y equals 3 times 1, which is 3, plus 2. 3 plus 2 is 5. So when x is 1, y is 5. Now I'm going to show you another shortcut here. And it's using the slope of the equation. So the slope of the equation here is 3. Which means if m equals 3, that is 3 over 1, right? A rise of 3 and a run of 1. So this is our change in y, and our change in x. Now I'm just going to do a little table over here. All right, so we've got our x and y, and we know, I'm just going to plug in some of the values we've got, that at 0 it's 2, and at 1 it's 5, and we don't know what it is at 2, and we don't know what it is yet at 3. But we can take our slope here, which is our change in y over change in x, so change in y over change in x. This is 3 over 1, right? This is the slope. I just pulled that from the equation. And I'm going to flip-flop these here. And then I can just use that to fill in the rest of my table. So this is saying that x should be a plus 1 and y should be a plus 3, right? So I've got change of y of a positive 3, change in x of a positive 1. I'm going to line those up with my table. And I'm going to just use that to complete the table. So this makes sense, right? We were given our x values, so this is a plus 1, plus 1, plus 1. And this should be a plus 3, plus 3, plus 3. So 2 plus 3 is 5, so that makes sense. 5 plus 3 is 8. 8 plus 3 is 11. So I chose that method instead of plugging in my x values. So this is two different methods you can use here. You can use your slope to complete your table and your y-intercept, right, because that tells you where to start. Or you can plug in each x value and then figure out what your corresponding y value is. So two methods. I know that's a lot for one question, but I want you to see those two methods. Okay, so we went ahead and completed this 8 and 11. So I don't care which method you use the one that works for you. And we use up a lot of space, but that's okay. We can get more. So now we're going to go ahead and look at question number 2 for 4.2, determining slope and y-intercept. And we're going to find our slope from this graph, which means we're going to find our rise over run, which is our vertical change, over our horizontal change. And so we're going to pick a couple points here on this. We want to find points that have clear intersections at x and y values. So I don't want to pick like this one here because it's not at an x and y value. You want to find ones that are at nice x and y intersections. And it doesn't matter. You only need 2 to determine the slope, but I just pointed out a couple in case you picked any one of these. And then I'm going to count my rise, so my change in y, and it looks like I go up 3. It's a positive slope. I'm going up to the right. And I'm just double checking, up 3. Yep, up 3 every time. And every time I go up 3, I'm going over 1. So my rise is a plus 3, and my run is a plus 1. So my slope is 3 over 1, or 3, right? So slope is 3. And now I need to find my y-intercept. So to do that, I'm just going to travel along my line here and find where it crosses the y-axis. So if I travel along here, I cross the y-axis right here at 1. And that's right, because each of these lines represents 1. And so at 0, 1, that's my b value. So b equals 1. Now if I was going to write this in an equation, I would write this out as y equals my slope, 3x, plus my b value, which is 1. And you didn't need to do that. It didn't ask you to, but I'm just kind of connecting concepts there. So slope is 3, or 3 over 1. And y-intercept is 1 because that's where we cross the y-axis at the y value of 1. And this would be the equation. Okay, let's go ahead and check question number 3, where it wants us to graph given an equation. So first thing I'm going to notice, this is non-proportional, right? It does not start at the y-axis, or sorry, it does not start at the origin. It has a point on the y-axis. My slope is 2, and my y-intercept is -3. So this is where we've got one of those negatives attached to it. So my slope, m, equals 2, which is the same as 2 over 1. So I'm going up 2, and over 1. This is a positive slope because there is no negative sign associated with this value here. My y-intercept is a negative 3, which means I'm going to start at the point 0 and negative 3. So I'm going to travel along my y-axis here until I get to negative 3. 1, 2, 3. So that's my b, that's my y-intercept. And then from there, I'm going to use my slope to create a line. So from this point, I go up 2 and over 1. And up 2 and over 1. Up 2, over 1. And then I'm going to draw my line. And I'm just going to go backwards here to get my line in all my quadrants. And then I'm going to connect my dots. So I used my slope of 2, positive 2, up 2 over 1, and my y-intercept of negative 3 to give me my starting point. All right, cruising through. Let's go ahead and look at 4.4. So it's asking us to look at this table and tell us if it represents a proportional or non-proportional relationship. So if you can recall, the first thing that we're going to do is check and make sure we have a linear relationship. So we're going to find our quotient, that's division, of y over x. So we're going to take all of our values here and find out what our quotient is, find out if we have a constant rate of change. So remember, y is on the bottom, x is on top, which is the opposite for our rate of change, or our constant of proportionality. So 4 divided by 1 equals 4. So I'm going to check the next one, which is 8 divided by 2, right? 8 divided by 2 over here on my table, which is 4. I'm going to check the next one, 12 divided by 3, 4. So far so good. 16 divided by 4 is 4. And the last one here, 20 divided by 5 is 4. Okay, so we have a constant of proportionality, a constant rate of change of 4, or 4 over 1. So that would be our slope. And then we're going to see if we cross at the origin. So we need to see what the value is when x is 0, what is the value of y. So we can use this to work backwards. If I'm adding, as I move this direction, a plus 1 on the top, right? And I'm adding on the bottom a plus 4, to work backwards, I can just subtract, right? So instead of plus 1, I'm going to minus 1, and that's going to get me to 0 already. So that was easy. So when x is 0, I'm going to subtract 4, because that's the opposite of what we did here. So 4 minus 4 is 0. Okay, so when x is 0, y is also 0. That means that this relationship is proportional, because it crosses the origin. So it is linear because it has a constant rate of change of 4 over 1. And it is proportional because if you work backwards, when your x value is 0, your y value is also 0. So it wants us to determine in number 5 if the graph in exercise 2, so we got to look back up here, that's this one. If the graph in exercise 2 is a proportional or non-proportional linear relationship. So it's linear, it makes a straight line, but does it go through the origin or does it not go through the origin? We determined that it has a b value of 1, right? So we can look at the graph and also see, does it go through the origin? No, it does not. So if it does not go through the origin, it's a straight line that does not go through the origin, it is non-proportional. And that's because b equals 1. b has to be 0 for it to be proportional. Then the next thing it wants us to do is look at the graph in exercise 3. So we're looking at this graph right here. Is this graph proportional or non-proportional? Well, it is linear, but it is not proportional because it does not cross the origin. It's got a b value of -3. So this is also non-proportional. And b equals -3. So the last question, number 7, is asking us to summarize basically what we just did in all of those all of those questions. So it's saying, how do you identify a linear, non-proportional relationship from a table, a graph, and an equation? Well, how do we do that? If we have a table, right, the first thing we check is, does it have a constant rate of change? Right? Oops. Change with an E. If it has a constant rate of change, then we check to see if it has a B value. So we work backwards to determine if what Y equals when X is 0. So we're trying to figure out when X is 0, what is Y? If Y equals 0, it is proportional. If Y does not equal 0, notice I crossed the equal sign out, then it is non-proportional. So I'm just abbreviating there. So that's for a table. If we have a graph, we want to make sure it's linear. So straight line. And then we check to see if it goes through the origin. Crosses. And again, that's just saying when X is 0, Y is 0. If it does not cross the origin, I don't need an equal sign there. So no origin equals non-proportional. Origin equals proportional. And I'm just abbreviating there for you guys. All you needed to be able to do is understand it. You can write the whole word out if you'd like. Wouldn't stop you from doing that. So table, check that it's linear, and then determine what Y equals when X is 0. So what does Y equal when X is 0? If Y equals 0, it's proportional. If Y does not equal 0, it's non-proportional. If we're looking at a graph, determine if it's linear, that means a straight line, and then determine if it crosses the origin at 0, 0. So it does not cross the origin, it's non-proportional. Crosses the origin, it is proportional. And finally, with an equation, we're looking again to see if it's in Y equals mx form or Y equals mx plus b form. If it's Y equals mx, where there is no b value, let the bell go. Where there is no b value, then this is proportional. If there is a plus b value, then this is. And remember, this makes sense because this is saying that when X is 0, Y equals this B value, right? So X is 0, Y equals B. It has and B does not equal 0. As opposed to this one, when X is 0, Y equals 0, right? Because there's nothing there. Okay, so that is your review. That is a little bit longer video than I anticipated, but gave you some options on ways to solve and hopefully gives you a pretty comprehensive review for each of these lessons. So tomorrow in class you will have a practice test covering this, and if you've got questions you need to make sure you're asking because we got a quiz coming up on Module 4. Okay, Math 8, that's all I've got for you. I will see you in class.